Let us talk about Python collections. When we talk about Python collections, we are referring to containers of data. In Python, the built-in collections include lists, tuples, sets, and dictionaries. So we're going to take a look at how we can create empty collections. Then we're going to create non-empty collections with data inside. After that, we're going to be accessing the data. We're going to make changes to the data. We're going to add and remove data. And finally, we're going to look at if we can sort the data. So to start off, let's go ahead and create some empty collections. And we're going to start off by creating some empty lists. If we want to create an empty list, all we need to do is we need to write a pair of empty square brackets. An empty tuple needs an empty pair of rounded brackets. For an empty set, you need to write something slightly strange. So over here, you need to write these curly braces. And inside the curly braces, you need to write a star and a pair of rounded brackets. And for a dictionary, all you need to do is write a pair of these curly braces. Then for each of the individual collections, you can also use the keyword method to create an empty list, set, tuple, or dictionary by simply using the corresponding keywords. So over here for a list, we simply write list with empty brackets. For tuple, we write tuple with empty brackets. For a set, we write set with empty brackets. And for a dictionary, we write dictionary with empty brackets. If I then go ahead and execute these individual print statements, you will see that the lists are in fact of the correct data type. So executing the first two print statements, you can see that we have two lists. Then below that, we have two tuples. Below that, we have two sets. And at the very end, we have two dictionaries. So that is exactly how we can create these empty collections. Moving forward, let's go ahead and learn how we can actually add data to these individual collections. To add data to a list, all you need to do is write the data within the square brackets, and you will have a list with data inside. Over here, I have just added some integers, a boolean, and some string values. For a tuple, you can do exactly the same thing, but you'll be using these rounded brackets. For a set, you can do exactly the same thing, but you'll be using these curly brackets. And for a dictionary, you need to watch out because for dictionaries, you always need to add items that consist of a key and a value. So over here, we have three keys, the 1, 2, and 3. And we have three values, which is the apple, the cherry, and the strawberry. And you want to bear in mind that when you use the keywords to create a dictionary, so when you write dictionary, you cannot add a list as an argument. So this won't work over here. And neither will the example below where we're using a tuple and inserting it into the dictionary keyword. So these two examples will return an error. But at the very end, I have these curly braces, and I'm adding them within the dictionary keyword, so that is going to work. So all this should show you is that you can create filled lists, tuples, sets, and dictionaries in several different ways. Now I do want to point out one more thing, and that is that whenever you create sets, you're going to be deleting duplicate values. So over here you can see that I have a set, and I have put that set within this list keyword. But when I go ahead and print this list, what we'll see is that the 2 is deleted, one of the A's is deleted, and in addition to that, what many people don't know is that the true will also be deleted. And the reason why this true is going to be deleted is because within the set, it is detected to be the same as the 1. So let me go ahead and show you that by briefly printing the result of list 6. You will be able to see that we get in the console output the values 1, 2, C, and A, and that is exactly what I just predicted would happen. So the true is deleted, one of the 2's is deleted, and the A is deleted. And that is also going to happen if you use the tuple and insert into the keyword tuple a set. So you'll see exactly the same phenomenon pop up over here. So if I go ahead and execute this, you will see that one of the twos has been deleted, the true has been deleted, and the a has been deleted. So just to bear that in mind, you should know that whenever you use these sets, the duplicate values always get removed. Now, how do we go about accessing data within these individual collections? If you want to access an individual element of a list, you can simply write the name of the list, and then within square brackets, you write the index of the element you want to access. And remember, with lists, the index starts with 0, then goes 1, 2, 3, 4, 5, and 6. And so over here, with this example, we're going to be printing the third element, which is going to be the true value over here. In addition to that, you can also access items from the back. That means over here you have a negative symbol in front of the number. And so if you want to access from back to front, this is going to have the negative index 1, this is going to have the negative index 2, this is going to have the negative index 3, and so on and so forth. So let me just show to you that that in fact does work. Over here in the console output, you can see the two results that we expect, which is first the true, which is the result of taking the third element over here. And in addition to that, you can also see the string C being printed out, which is the result of taking the negative index over here. In addition to that, you can also use the slice method, which gives you the elements between two indices. So if you want to take elements between two indices, you have to use a starting index, then the colon, and then an ending index. So if I go ahead and execute this slice over here, you get the elements 1 and 2, which corresponds to the first elements over here. So these two are the result of this slice. With tuples, the access to data is in fact very similar to lists. So if you want to access an index by item, you can do that in pretty much the same way you would with a list. You can access items from back to front by using negative indexes, and then you can also use the slice method that I demonstrated above. With sets, it's a bit more complicated because you cannot access individual items. Sets are by definition unordered. So if you try and access a set value using an index, as I have done here, you're going to get an error. You can try that, but this will not work. For dictionaries, the access to data is also quite interesting because you always have to deal with these key value pairs. So if you want to access the value of a specific element at a specific key, you write the name of the dictionary and then the key value in square brackets. So this is going to give you the element cherry because it is the value at the key number 2. If you want to access all the keys, then you simply write the name of the dictionary and then dot keys. If you want to access all the values, you can write the name of the dictionary and then dot values. And finally, if you want to access all the items, which consist of a key and a value, then you simply write the name of the dictionary and items. And let me just briefly execute that so we can see that it also works. And let me make it a bit bigger. So yeah, this has worked just the way that we expected it to. So over here we have accessed the dictionary item at the key 2, which is cherry, and that is this output. Then we have accessed all the keys, which was the second printed output. Then we have also accessed all the individual items, and then finally the key value pairs, which is down here, always given by a key and a value. Let us now move on to changing the entries in these individual collections. If you want to change a value within a list, you have to first access it by writing the name of the list and the index of the item you want to change. So in this case, we chose the item number 1, and since the first element has the index 0, the second element has the index 1. So we're changing this 2 into the value 15 in this case. So by printing out this list over here, you'll see that the second item has changed to 15. So if we pay attention to the 2 over here and the 15 over here, that is exactly what has changed. How about changing the value of a tuple? Now, tuples are what we call immutable. Immutable simply means that after you've defined a certain tuple, you cannot change it anymore. So trying to do the same thing as we did above with lists will fail, so that will not work anymore. How about changing the value in a set? Now, changing the value in a set won't work either, because sets are what we call unordered. The order of the elements in the set is not given specifically. So we cannot access the individual items by using an index, and that's why we cannot change individual items. So this is not going to work either. Then finally, with dictionaries, we are able to change individual items. Let's try and change a specific entry. Let's say we want to change the apple over here to a banana. Then we need to write the name of the dictionary, the key of the item we want to change. So over here, since we have the apple at key 1, which we want to change, we need to write the key into these square brackets and then assign it the new value, which is banana. And subsequently, if we execute this, you can see that now the banana is given in the list, in the dictionary, instead of the apple. And now let's say that instead of changing a value, we want to change the key of an item, because remember, these dictionaries also have keys. So let's say we would like to change the key of the cherry to the number 4. So instead of the number 2, it should be 4. The way to do that would be write the name of the dictionary, then the key of the item you want to change, and then write dictionary and then pop and then the index 2. So if we go ahead and execute this, you'll see that the cherry over here has been changed because the key of the cherry is now 4 and not 2 anymore. So this is how you change the key. Next up, let's talk about adding and removing values from these individual collections. Starting off again with lists. Let's say we want to add a value. The way to do that is by using the keyword append. So we're appending the string D to this list. If we go ahead and print it after we use this append statement, you'll see that down in the console output, we have this D which has been added to the end of the list. Similarly, if we want to remove an item from the list, we can go ahead and use the keyword pop. And so now we are popping the element at the index 0, which would be the 1 over here. So you'll see that if we print the list afterwards, the 1 will be gone. Let's see if that does apply. And yes, that is exactly what happens. Down here, you can see that I've popped it once and accidentally executed twice. So after the first execution, you can see that the very first element was popped because the 1 is missing over here. And then since I executed it again, it popped one of the 2s. So every time you execute this statement over here, you will see that the very first index element will be gone. So I can actually go ahead and pop through the entire list by executing the statement over and over again. Let me go ahead and do that a couple more times. And you can see all the values are gradually gone. See, now the list is empty because I've popped away all the values. With tuples, we again have the problem that they are immutable. That means we cannot change them after they are defined. So there's no adding or removing entries in this case. Moving on to sets, we can actually add values to a set by using the keyword add. So over here, we have a set of numbers and we are adding the value 12 to this set. So if we go ahead and run this, you can see that now the set has the value 12. And in addition, remember that the set automatically always removes the duplicate values, so you won't be seeing two A's, you won't be seeing two 2's, and you also won't be seeing this true value, because as I stated earlier in this part, it is considered equivalent to the 1. But you will see the 12 now that it has been added. And you can also go ahead and remove individual values from the set, but you can't specify what values you remove, because it is always going to remove a random value, because you cannot pass in any index, because these sets are unordered. So let's go ahead and remove a couple of these values. So if I go ahead and execute this a couple of times, you can see that now the set has become quite small after a couple random values have been popped away. And last but not least, let's talk about how we can do this with dictionaries. So how can we add and remove items from dictionaries? Over here you can see I have dictionary number 9 with a total of 3 items, and I want to add the 4th item, and I do this with the word update. So if we go ahead and update the dictionary, you can see that now the dictionary also has this banana, which I chose to insert. And if we want to remove an element, we can simply write the index of the element we want to remove and then pop it from the dictionary. So let me go ahead and execute this. And now you'll see that the apple has been removed from the dictionary down here because I have popped it. So that is how you can add and remove data from these individual collections. Last but not least, let's talk about sorting the data in collections. When we talk about sorting data, there are really 2 possibilities, either by using the method sort or by using the method sorted. Now there is actually a difference between these two, which is that if we use sort, we are making changes to the original collection, whereas if we use sorted, we are simply returning the sorted collection. There is a distinct difference, and so if we try and look at what that means for sorting the individual collections, if, for example, we have a list over here and we want to return it in ascending order, we can go ahead and sort it and print it out. So let's go ahead and do that. And you can see that it has made this list such that each of the items is arranged in ascending order. But similarly, we could have also used the sorted method, because over here it returns the value. So if we go ahead and execute this, you can see we get exactly the same result. Now, as I mentioned just a moment ago, and this is pretty difficult to wrap your head around, but bear with me, if I would have taken this sort and put it into the print statement directly, I would not get any result. So let me show you that. If I execute this, I get none. And that is because the sort does not have any return value, whereas the sorted value, which provides a copy of the original list and sorts it, does have a return value. So as I mentioned before, bear that in mind, that when you use sort, there is no return and it makes changes to the original collection. But here with sorted, no changes are made to the original collection, but a returned copy is made that is sorted. And another thing that you should bear in mind is that if I were to want to provide a list which is given in descending order, I can simply write reverse equals true. And if I go ahead and execute this, you'll see that now the reverse order is given of the list, which is really nice. So moving on to tuples, as I stated a moment ago, the sort method cannot be used because we're making changes to the original. And as we stated earlier, tuples are immutable. That means after they've been defined, they can't be changed anymore. So the closest we can get to sorting anything with a tuple is in fact by using the sorted method. which simply returns a copy which is sorted in ascending order. So if we go ahead and execute this, you can see that we get a list printed out. And I mean, bear that in mind, that it is in fact a list, a sorted list, and it is not a tuple anymore. And it is now given the numbers in ascending order, as you can see down here. Now moving on, let's talk about the set. And with sets, it's of course pretty difficult to sort them because they are by definition unsorted. So one thing that we can do is use the sorted method again, and it will return the numbers in sorted order. So if I go ahead and execute this, you can see the duplicates are deleted. So the number 2 is deleted, the number 1 is deleted, and then the rest of the numbers are put into ascending order, as you can see down here in the console output. Now finally, with dictionaries, can we sort dictionaries? Yes, we can. By using sorted again, over here we have got the dictionary number 10, and if we use sorted on this dictionary, it is going to return the dictionary with ascending key numbers. So now you can see, after I've sorted the dictionary, the numbers 1, 2, and 3 appear down here in the console output, and that is because it has sorted the keys. Now, if I want to obtain all the items, I could equally write items behind that. Items, or wait, hold on, does that work? Oh no, I have to write it over here. So dot items, and it would do exactly the same thing, but now it would sort the items also by the key, but it would also output the value as well. So that is how sorting works with these individual collections.